Sound check. Hello. Good afternoon, everyone. Good afternoon to my 19 students watching right now. Kumusta kayong lahat dyan? Sino yung mga nanonood ngayon, be? Okay? Sorry if wala ako kanina, no? I asked Sir Batusin again na mag-ano kami? Magdiretso na lang ba? No, straight discussion na lang instead of swapping morning and evening. No? Since parang pareho lang man. No? And also, I had to rest for my throat again. Like, you couldn't believe it. Napaka-sensitive ng throat ko this past weeks, no? Or months. You have noticed, di ba? No? And been planning na surgery ko na to this summer, no? Baka ipa-immunize or maybe worse, ipatanggal ko na talaga yung tonsils ko. Since parang sensitive na. Okay? So, good afternoon. TJ, Kat, sino pa ba yung mga andito? Sila lang yung mga attentive, no? So, our topic for this afternoon is physics, no? Yung dynamics, but not just limited to dynamics, but physics, no? From the Giancoli book, Physics by Giancoli, no? Yung author ng libro, si Douglas C. Giancoli. Napakaraming problems taken from that book. So, if you would open your Padlet, yung 2024 resources ba? No, I'm gonna open it ba? Padlet. Wait mo na. Ha? Saan ba yan? No, not this. Okay, give me a sec. Ba't di ko nakikita yung ano dito? Padlet dito. Yan. Okay? So, sa Padlet, di ba, I uploaded the resources in 2024 resources that I uploaded, no? I want you all to download the physics na PDF file I uploaded. Kini ba? Na textbook and the solutions manual. Napakaraming problems na kinuha ng examiner from this book, no? Yeah, no? Not just mga example problems, yung mga example problems almost lumabas na lahat pero meron pang hindi pa, no? So, unahin mo yung mga example problems in each in this chapter, then yung mga supplementary problems, no? Yung mga practice problems in this chapter and their solutions can be found dito sa in-upload ko, no, na solutions manual. Okay? Pwede maglaan ka ng 2 to 3 days, no? Dito, like focus ka lang talaga sa physics or if pwede 5 days, no? For this remaining how many days na lang ba? 20 days no, before the board exam, mag-focus kayo. Okay? So, let me explore muna and show you problems that had come out sa board exam. Now, from this book. Okay? Wait muna ha. Pakita ko muna. We'll have examples, of course, no? Today, pero so that you would know ba ano yung mga hahanapin na from this book. Ito na. PDF. Yeah. Ito, no? This is the reference book. Okay? Now, yung mga lumabas na dito, okay ha? Example, kini siya. Punta tayo dito. Ito, parang lumabas na sa board exam. Okay? Example 4-3. Okay? Ito, wala pa. Binigay ko ito sa ano, sa inyo, no? Last module. Okay? This one, I think, had come out already. No? Wait. Yung mga lumabas na. Yung satellite na ano. Satellite na problem. Okay? Ano yan? Ito. Lumabas na ito, no? 2017 board exam. Okay? 2017 board exam. Na example 5-12, no? And even up to last board exam, nagkuha siya ng mga problems from this book. Okay? Ano pa ba yung mga kinuha niya? Ito ay itong bouncing ball problem that came out last exam. Ito, this problem number 52. Yan. He gave that one. Now, this problem. Okay? So, do not limit na on solving mga example problems. Mag-solve ka rin ito ng mga example problems. Ay mga additional work problems ba? No, additional problems sa book. Okay? Wait muna ha. Another problem that he gave last board exam. Wait. Yung torque. Yeah. Yung net torque problem. Okay. Net torque from the MSTC na exam, he gave this torque problem na maraming na shock, no, kasi daw pang mechanics daw ito, no, still physics, no, mechanics is still part of physics, di ba? So lumabas yan. So there is a big chance that the examiner would take problems naman from this book, especially those mga malalapit lang. Like for example, number 26 or maybe number 24, no? Ganun. Okay, another problem yung power problem na binigay ng examiner, which I will discuss later, no? Okay, parang lumagpas na ako. Yung merong car. This one. This problem came out parang, if I'm not mistaken, May 2017 or May 2018, no? Then this one naman, this next follow-up problem came out naman the next exam. No, I forgot when exactly. Okay, but they came out. Now the examiner took this problem. So malaking chance na ibibigay niya ito. No? So ganoon yan, guys. Okay? Study the resources ng examiner. Okay? That's what made me top the board exam noon. No? When I find out that the examiner has been taken problems from Engineering Mathematics by John Bird. Yan yung author ng book, no? When I examined his type of problems and yung book, no? Na-notice ko, pareho lang man. So, I studied the book, especially yung mga probability and mga calculus, no? And during the board exam, napakaraming lumabas, no? Sa amin, taken from that book na master ko na. Okay? So that's how to be wise by in studying. No? So please, magano ka ng oras, no? Maglaan ka ng oras, no? If pwede, kayo magkaklase, alternate kayo, no? Solve this, siya naman ito, then discuss para ma-master ninyo, no? Ganun. Okay? Yes, sobrang rami, no? Pero if simulan nyo as early as possible, marami kayong matatapos, no? And I'm gonna repeat this, no? Hindi namin kayang maibigay lahat. Di ba? Sobrang raming posibleng ibibigay ng examiner. Hindi namin kaya na ibigay lahat. But of course, pwede naming ma-discuss, no, yung mga principle, no, behind these topics. Okay ba? So, discuss tayo, no? Some of the problems na posibleng lalabas. Nakapag-discuss na ng, of course, physics si Sir Tariga, no? And sobrang ganda ng presentation niya. I rewatched it last night and I love the discussion, no? Like how I wish I had that kind of instructor noon, no? Of course, Sir Diego was enough, pero iba din yung dating ba? Iba yung way ni Sir Tariga. Galing talaga ni Master, no? So let's have problems, no, na the same topic sa mga na-discuss na ni Sir Tariga, pero problems taken from this book. Okay? Let's start with this one. A truck of mass 1,000 kilogram is connected to a 400 kilogram lug by a weightless stretchable rope. The driving force exerted by the ground on the truck is 2,000 newtons. The force of friction exerted by the ground on the lug is 600 newtons. Assuming that the ground is level, determine the following: the rate of acceleration of the system and the tension in the rope which connects the truck and the lug. How would you solve that one? Okay? Of course, no, yung una mong gagawin is mag-draw ka ba, no? Draw ka. Merong isang truck na connected to a 400 kilogram lug. Ano ba yung lug? No? Parang trunk of a tree. Yan. This is the lug. No? So, connected by a weightless, unstretchable rope. This is the weightless, unstretchable rope. The mass of this truck is 1,000 kilograms and the mass of the lug is 400 kilogram. Okay? So, mag-draw ka lang ng simple, no? Pwede lang simple na truck. No, pwede nga, square na lang. Ito yung truck. Ito yung lug. No, that's how you may draw it. No, basta alam mo that is supposedly a truck. Sige, lagyan mo ng ganyan. No? This is the lug. Di ba? You don't have to make it perfect like this, no? Kana siya. Next. Sabi dito, the driving force exerted by the ground on the truck is 2,000 newtons, no? Like as it travels. Okay? So as these wheels roll, parang yung force na ini-exert ng ground to the wheels is 2,000 newtons. No? So effectively, there is a parang pushing force, no, na 2,000 newton na as nag-roll yung wheel, di ba? So, dapat papunta doon to the right kasi it causes the track to speed up or to go to the right, di ba? So, dapat ganun, 200 newtons. Okay? Parang resultant yan, no? All the forces that act dito, no, sa mga wheels, no, effectively, it pushes the truck, no, with a force of 2,000 newtons. Okay? Now, the driving force exerted by the ground on the truck is 2,000 newton. The force of friction exerted by the ground on the log is 600 newtons. So, it goes, of course, to the right. So, dapat the friction is opposite the motion. Always yan, no? Since it goes to the right, its acceleration is to the right, or its motion is to the right, then yung friction is always opposite the direction of the motion. Now, to the left, yung friction, 600 newtons. Now, assuming that the ground is level, okay, hindi ko na lang dreno yung ground, no? Basta level yung ground. Question, determine the rate of acceleration of the system. Now, what is your idea, be? Now, what formula yung parang nasa isipan ninyo papasok, no? The moment you encounter this problem. Now, I wanna know. You don't have to tell me the whole solution, but what is the principle you think na useful nito? Sige daw, be. Sabihin niyo daw sa akin dito sa Facebook or sa Padlet. Anong principle gagamitin dito? Okay? Sagutin nyo. TJ, Kat, Josh, at sino pa dyan, no? Yung mga nakikinig. Sabi ni Josh, F equal to MA. Sabi ni TJ, rectilinear, sir. Rectilinear motion. Aha. Hello po, sir. Pasensya na po. Pero pwede po ba palakasin yung mic, sir? Hala. Oh, no. Ayun ko lang na-realize na hindi pala malakas yung mic. How about this one? Okay na ba? Yes, sir. Thank you po. Okay, good. Good. Sorry about that, no? Na-adjust kasi last night. Nagamit ng wife ko. Sabi sa akin, sorry. Okay. So, sorry about that. Anyway, merong tarang tama dito, no, si Josh. Sabi niya, F is equal to MA. Yes. Okay, yan yung gagamitin. Since there is an acceleration, then there will be a reverse effective force. No? It's like a force that goes opposite the direction of the acceleration. No? So, ito yung gagamitin. Summation of forces is equal to mass times acceleration, di ba? From the second law of motion, no? From the Allenbert's principle. Okay? Always yan yung gagamitin nyo whenever you're asked to find the acceleration, no? And merong forces involved. Okay? Hindi lang rectilinear. No, but kinetic ni siya. Kinetic na din siya na topic, hindi na kinematic. So, dapat yung forces na positive or yung forces towards the direction of the acceleration. Okay? So, summation of forces equal to mass times acceleration. 200 minus 600, kasi this is a resisting force. Like, take this as if one system siya. You don't have to find or to cut this rope so that you would express the tension yan. No need. No, pwede lang take this as one whole system. That is summation of forces 200 minus 600 is equal to 1,000 plus 400 because they both have the same acceleration, then times acceleration A. Okay? Okay. No? And evaluating that would give us acceleration equal to 1 meters per second squared. Napakadali lang. Napakadali lang. No? Now, second question dito. Determine the tension in the rope which connects the track and the lug. So, how to find the tension in the rope? So, pwede natin i-cut, no? Yung rope, that's it. No, and this is the 400 kilogram lug and the resisting force on the ground is 600 Newton. Okay, so to find that tension is equal to, tension minus the 600 Newton, again, summation of forces equal to mass times acceleration. No? Equate it to 400 times 1. No, 1 meters per second squared. No, yan yung acceleration na na-calculate natin. So, the T is 1,000 newtons. Okay? Yan yung tension by 1,000 newtons. Ayos ba? Okay. Now, next naman. How about this one? A wooden plank is raised at an end until an angle of 30 degrees is achieved. No? Hindi ko nalagyan ng unit. Sorry about that. Okay. 30 degrees dapat na sabay. Yan. A 2 kilogram box is placed on the incline 1 meter from the lower end and given a slight tap to overcome static friction. The coefficient of kinetic friction between the box and the plank is 0.2. Determine the rate of this acceleration of the box down the incline and also the speed of the box at the bottom. Assume that the initial speed of the box is 0. Okay? Paano to? So, huwag kayong ma-worry sa problems like this, ha? Parang, medyo malapit lang siya sa statics, di ba? Close to a static problem lang. So, of course, if you are asked to find the resisting force or let's say the impending force to resist the block from sliding, you know how to do that. Diba? So this is the plank. Okay, incline siya 30 degrees. No, and say the box, is placed dito. The mass of that box is 2 kilograms, and it slides down, okay, 1 meter. So we're asked to find the acceleration and also the speed of the box at the bottom, after it has slide down 1 meter. So paano natin ma-solve yan? Okay, ganito lang, simple lang, parang statics lang first. First, calculate natin yung weight. Diba? Yung weight is equal to mass times gravity. No, 2 times 9.81, that's 19.62 newtons. After that, kunin natin yung normal reaction, 'di ba, sa Planck, no? And the normal reactions should be equivalent lang to the normal component of the weight. Now, let's denote that as W sub n. W sub n, equal yan to W cosine theta. I know you know na, no? W cosine theta lang. If theta is the angle of inclination nito, same yan with the angle from the vertical, no, of W and Wn. So, Wn or Rn is 19.62 newtons the weight, then cosine of 30 degrees. Evaluating that, that's 16.99 newtons. Okay? 16.99 newtons. And the reason why kinuha natin yung normal reaction is because we need to find the the friction. Kasi if this happens to be frictionless and we are to ask to find the acceleration, no? Then no need for us to solve for this reaction kasi hindi man siya makaka-apekto, only the tangential component lang man. Tangential component, no? Which is W sine of theta is equal to is equal to m times a, no? So the acceleration would be the parang W parang sin theta, di ba? Parang ganun. O G sin theta. Anyway, for this, we need to find the frictional resistance, kinetic friction yan, and that is mu k times Rn. No? Our mu is 0.2, coefficient of kinetic friction, that's 0.2 times 16.99 newtons, that is equal to 3.398 newtons. Now, yan yung resisting force. And yung force that causes the box to slide down is the tangential component, di ba? Yung W sub t. So, that is W sine theta. 19.62 sine of 30 degrees is equal yan to 9.81 newtons. Kaya yan yung tangential component. So, yung acceleration, makalculate natin by using the same formula. The summation of forces is equal to mass times acceleration. No, and that is W sub t. Okay, that is component downward, no, is equal to, minus pa pala tayo, minus the frictional resistance, dapat along the direction of the motion lang ha. Acceleration is downward, so yung components na ma-involve dito are these forces lang, Wt, tangential, and the frictional resistance. And that is equal to mass times acceleration. No, and acceleration is W sub t minus F sub k over m. So that is 9.81 newtons minus 3.398 all over 2, and that is equal to 3.206 meters per second square. Okay, that's how to find the acceleration. And part B, speed of the box at the bottom. So in calculating the speed of the box, since we already got the acceleration, and we know as well the, given as well yung speed, initial speed, that's 0, no, and given naman yung distance, 1 meters, then we can use this formula. No, the formula that involves these four, initial velocity, distance, acceleration, and final velocity is this. Square root of v squared plus 2as. Diba? So, square root of 0 squared plus twice of 3.206 times 1, and that is equal to 2.532 meters per second. That is the velocity when the block arrives on the ground. No? I tried to give a problem like this sa previous batch, but it was a child na nag-slide down, No, but similar lang, I asked for the acceleration, I mean the velocity, when the child arrives at the bottom, no? At the end of the slide. Ito lang yung operation, konti lang yung nakakuha. No? Even though madali lang, no? Parang static lang dito. Parang static lang siya. No, but instead of summation of forces equal to 0, we are to make it summation of forces equal to mass times acceleration. That's how we solve for the acceleration. 'Di ba? Kasi merong acceleration, no? Then after that, kinematic formula, V squared is equal to V sub O squared. Okay, I forgot to include, no, na dapat V sub O yan by V sub O, initial or speed at time 0. Okay? Speed at time 0. Okay? Somebody asked me, Sir, saan po ito sa Module 5? Po ba ito? Hindi. Miscellaneous class tayo ngayon. Okay? Miscellaneous class. So we can discuss additional problems na wala sa module. No? Tomorrow pa tayo mag-discuss ng Module 5. Okay? Tomorrow pa ba? Okay pa ba kayo dyan? Nakikinig pa ba? 46? 45 viewers? Okay. I want you to practice this, be. You know. I-practice daw. That could come out sa board exam ninyo. No? And we have a lot of time right now. Sige daw. Please, challenge yourself na masolve nyo ito within few minutes, no, or seconds. The same lang ito. Parang somewhat, related lang. No? Or in fact, pareho lang. No? So, tell me, dito sa Padlet or sa group at sa Facebook, no? I-comment niyo yung sagot niyo sa letter A and letter B. Okay? I'm not gonna proceed if walang mag-submit, no? If hindi aabot ng 10, hindi ako mag-proceed. Gusto ko makita na alam niyo na yung problem na ganito, no? Alam niyo na how to solve. Hindi lang hanggang sa utak, no, na ay, I understand the principle. Dapat matest niyo talaga yung sarili niyo. Go! Okay. You might be wondering, sir, walang given na mass, no? Kanina meron, no? It was a 2 kilogram box. Ngayon naman, wala. Ba't ganun, sir? How can we solve this if kulang? Well, kanina kasi, makancel lang yung mass, no? Parang pwede lang makancel yung mass. Take a look at the solution we had kanina. Tingnan ninyo. Diba? W sub t is W sin theta. W is mg. Fk is mu Rn. Rn is W cos sin theta, which is mg. W is mg. So, makancel siya effectively. No? Cancel siya effectively. So, if we'll go back there, pwede, i-assume natin yung mass, lang natin, i-variable natin. Dito na, sabi dito, M lang yung mass, M. Yan. So, wag kang discourage kaagad, no? Na, walang, given. Okay? Anong sagot nito? Okay? If i-follow ko yung formula kanina, parang ang magiging solution niya is ganito, no? The acceleration would be equal to the tangential component mg sin theta then minus mu k times mg cos sin theta then all over m. Okay? Hindi ko pala naipakita yung sinulat ko dito. Sa MathCAD. Wait muna ha. Ipakita ko lang. Wait. Okay. If i-follow ko yan ba? WT is mass times gravity, no? Times sine of theta. Okay? W sine theta minus Fk, which is coefficient of friction times the weight times cos sine theta. This is kasi the component, no? The normal component. Then over m. So, ibig sabihin yan, yung acceleration is just equal to g sine theta minus mu k. Hindi pala ma-shortcut, no? Mu k g or g mu k cos sine theta. Yan. Okay, or pwede siya maging A is equal to g then times sine theta minus mu coefficient of friction cos sine theta. Ito yung magiging formula, di ba? Ito yung magiging formula, no? Like regardless kung ano yung mass or ano yung weight, if there is no additional force involved, only the weight that causes it to slide down on inclined plane with an angle theta, the acceleration is 9.81 meters per second squared. Okay, ano nga yung mga given kanina? 9.81, then sine of theta, sine of 22 degrees, then minus mu, which is 0.12, cosine of 22 degrees. Okay? So, evaluate natin to, no? Kung ilan to. And that is equal to 2.583. No, yan yung sagot by. Okay? Yan yung sagot. Kanina, di ba? If follow natin, no? Yung problem kanina, the given coefficient of friction was 0.2. Palitan natin to ng 0.2. And the angle was 30. No? Kahit ano pa yung mass, the acceleration is always 3.206 meters per second squared, the same with what we got. No, basta the angle is 30 degrees and the mu is 0.2, no? So pwede siya ma-shortcut, pwede siya ma-formula. May mga ganun yan, guys, no? If you see a common problem, pwede mo ma-memorize na yung formula na yan. Like, instead of solving it the right way, pwede diretso ka na lang. Evaluate like this. Diba? Ilan ba yung nag-submit? Good. Dalawa lang pala. Si Maria lang at saka si TJ. Sila lang yung exempted ko sa board exam. Okay? And yung next one, if it starts from rest, the same as this problem, no? Starts from rest man ito. Yeah. The final velocity, the final velocity is equal to 0 squared plus 2as. 2 times 2.583, then the distance daw is 9.3. Okay, so 6.931 meters per second. Okay, 6.931. Plus 75 sa board exam. Sana all. Okay. Now, what if ganito be? What if ganito? Suppose the coefficient of friction, of kinetic friction between MA and the plane is 0.15. Hindi ko nalagyan ng animation yung ano da. Teka lang. Wala pala itong mga animation. Wait lang ha. Lagyan ko lang ng animation. Just give me a sec. Yan. Okay, ito na. Okay na. Suppose the coefficient of kinetic friction between MA and the plane is 0.15, and that m sub A and m sub B is equal to 2.7 kilograms. As m sub B moves down, determine the magnitude of the acceleration of MA and MB given theta is equal to 25 degrees. Okay. And also, what is the smallest value of the coefficient of kinetic friction will keep the system from accelerating? So, paano yan? Ganito lang, no? To find the acceleration, also the tension, so pwede rin yan yung itatanong. So, focus tayo dyan sa MA. No, their weight, by the way, are the same because they have the same masses. 2.7 kilograms, so times 9.81. Their weight is 26.487. No, both of their weights is 26.487. So, the kinetic friction, by the way, it accelerates. Papunta doon. No, it's clearly papunta doon. Bakit? Bakit hindi siya papunta sa baba along the incline? Well, yung component na lang kasi nito is maliit na lang compared to the weight dito, di ba? So, mas mabigat to. This M sub B than the M sub A. No? So, it should slide down. Okay? Through dito. Di ba? Dito sa right side. Left side. So, it accelerates up along the incline, but down. No? Down of the M sub B. So, the mu K is equal to W sub A cosine theta. Again, component that we discussed kanina. No? Normal component. So, that's 0.15 times 26.487 cosine of 25 degrees. That is equal to 3.606. Again, this W cosine theta is the reaction yan. That is the normal component. So, reaction siya sa bottom. So, the FK is ganyan. Now, 3.601. It opposes the motion kasi the motion is upward. Now, and the tension is papunta doon, and that is not equal to the corresponding weight of mass B, of object B. Kasi this is moving, this is accelerating. Now, hindi ito static na kung ano yung tension dito, the same din dito. And since this has a weight equal to this, 26.487, then tension is the same dito. No, it's not a static. Hindi ito statics, di ba? But, dynamics na. No? So, to find the tension and to find the acceleration, involve natin yung forces towards that direction. Since papunta dun yung acceleration, no, upward, then the forces upward along the incline are positive, downward naman negative. So, yung W sub T dito is i-minus mo yan. And that is equivalent to W sine theta. So, the tangential, 26.487 sine of 25. That's 11.194. So, summation of forces equal to mass times acceleration. Now, that is equal to T minus W sub T is equal, minus F sub K is equal to mass A times acceleration. No? And we can express T in terms of A, 2.7 yung mass, times acceleration, then plus this, no? These two, W sub T plus F sub K. If we add natin sila, 3.601 plus 11.194, that's 14.795. Okay? So, this is the tension in terms of the acceleration. And equate natin yan if we focus naman dito sa B. Dito sa B, if the tension is T, and of course, the same yung tension nila, no? Kasi walang friction yung pulley, no? It's frictionless. So, focus naman tayo dito sa mass B. the direction of the acceleration again is downward. Downward. So, dapat the forces downward must be positive. Again, summation of forces is equal to mass times acceleration. Now, for block B, the positive force is the weight, the W sub B, minus T is equal to mass times acceleration. W sub B is expressing T in terms of A, no, like i-transpose sila, swap, that is 2.7, the weight of B, which is 26.487, so downward weight na siya by, no, downward weight, ito yon. Then minus mass 2.7 times acceleration, and in-equate natin sila, no? Dapat the tensions are the same, diba? And we can solve for the acceleration, and that's 2.165. This is in meters per second squared. Okay ba? Okay? So, pwede na, no, if ever included yung tension ipapahanap, proceed ka, no? Substitute this calculated acceleration either dito or dito. It's up to you. No, I'm not gonna include that since that is not being asked. Pero if ever it is substitute mo. But pwede rin guys, now we are to take this as one system. One system that goes that direction. Ganun. No? Like summation of forces equal to mass times acceleration, and dapat yung forces pag ganun is positive towards that direction, no? And yung opposing force niyan is negative. What do I mean? Yung positive force dito that causes it to go down is W sub B, no? Then ito naman is a opposing force, no, towards the direction of the acceleration. So, i-minus natin, and as well as the kinetic friction on, bottom of block A. And then, equate it to the sum of the product of mass and acceleration. Ganun dapat. So, mass times acceleration, 2.7 times A, no, then 2.7 times A. The same yung acceleration, of course. So, 26.487, I meant that the weight of B, no, going down. Okay, then minus W sub T, yung na-calculate natin, and minus the kinetic frictional resistance. Okay, then equal to 2.7A plus 2.7A. Dapat isa-isahin mo. No, pwede i-group, i-times 2 mo since they have the same mass. No, but pwede rin M1 plus M2 quantity A at quantity times A since they have the same acceleration. Okay? 2.7A plus 2.7A. So, evaluating that gives us the same answer. Now, and dito natin makukuha yung value ng mu k, the smallest mu k that will keep the system from accelerating. Ibig sabihin yan, mag-zero na yung acceleration. No, it will keep the system from accelerating. So, to get that acceleration, pwede natin gamitin ito. But ngayon, dapat the f sub k is now a function of mu. Mu k, yan yung hahanapin, times WA cosine theta. Okay? And W sub B is 26.487, W sub T, 11.194, walang nagbago dyan. At dito, minus mu K times WA cosine of 25. Ito yung W sub X. I mean, W sub T times mu F sub K. Equate it to 0 so that walang mag-accelerate. Walang acceleration. And solving for mu K, it's 0.637. But let me show you a formula nito. Ito yung formula ay 1 minus sine of 25 degrees over cosine of 25 degrees. And you would get the same, 0.637. Andyan pa ba kayo? Kung meron kayong mga katanungan ha, please just tell me so, no? Tanungin niyo lang ako kung ano yung mga katanungan ninyo. Ano, na-stress na po ng ano ni sir. I want you to solve this, be. I want you to solve this. Wala nang inclined na plane, but dalawang objects with different masses, elevator and a counterweight. So with that, ilan yung acceleration, ilan din yung tension. Sige, go. I'm gonna give you time, no? Dapat ma-solve ninyo. I forgot if lumabas na ba ito, no, sa board. Pero baka sa board exam ninyo, no, lalabas na. Sige. Hello po sir, ask ko lang po if what time po yung break. I have errands po kasi plan po kasi sana isabay sa break time. Thank you. Anong oras tayo 7 tayo mag-break. 7 p.m. Okay? Dali, if you would solve this one, meron kang ma-derive na formula. Okay? Meron kang ma-derive na formula. Ito ay, Ito yung ma-derive mo na formula. This is taken from the book, no? Yung ma-derive mo na formula is this. M sub E minus M sub C over M sub E plus M sub C times G. Okay, yan yung ma-derive. Okay? So, bakit ganun? Bakit ganun yung formula? Okay? Before I'll show that to you, ganito ay. Let me show it sa MathCAD. No? Bakit ganun? Okay? If mag-focus tayo sa sa elevator, yung mas mabigat ba, di ba? M sub E is 1,150. Okay? So, dapat summation of forces is equal to mass times acceleration. Okay? Sa MathCAD ko lang isulat ha. So, yung forces supposedly is mass of the elevator times gravitational acceleration. Okay? Kasi it's going down there, no? Wait. I-draw ko yung figure. O, i-screenshot ko na lang. Yung dalawa. Ito eh. Okay. Ito yung parang free body diagrams nila. No? So, going down yung elevator, going up yung counterweight. Tama? No? So, dapat mass times gravity, this is its weight, minus the tension. Pwede, hindi include, no? I-minus natin yung weight, no, of the other one, no? Bali, take this as one system ba? Take this as one system na it goes that direction. Okay? One system. So, dapat yung weight na going down is positive, no? Yung mass, yung weight ng elevator, no? W sub E. Then, i-negative natin yung weight ng counterweight. No? I-subtract natin kasi the acceleration is towards that direction, not to the left, di ba? So, minus mass times mass of the counterweight times G okay, is equal to the sum of the mass times acceleration. Okay, is equal to mass times acceleration. So, dapat i-add natin to. Mass of the elevator plus mass of the counterweight, no? Times G. Okay, always ni siya i-add. No? Always yan i-add. Okay? Basta yung direction of our force is towards the direction of the motion. No? It's always opposite, no? Yung reverse effective force. So, if we're to solve for the, acceleration A pala ito. If we're to solve for the acceleration, that is equal to mass, i-minus natin to, no? Then, i-add natin yung denominator times G. Okay? So, yan yung formula. Yan yung formula. Okay, from now on, no? If merong heavier na object, kaya yan yung i-subtract, okay, or subtrakan, this is 1,150 minus counterweight 1,000, then denominator i-add natin yung dalawa, then multiply tayo ng 9.81. If the units are in pounds and feet per second squared, no, 32.2 natin yan. Okay? So that's it. That is the acceleration in meter per second squared. Ayos ba? Ganun lang. No? And if tension yung kukunin, pwede ka na mag-focus sa sa isa, no? Yung mass times the mass of the elevator times gravitational acceleration, which is G. Okay, downward na siya, di ba? Then minus tension is equal to that same mass times acceleration, no? So, yung tension is equal yan to the mass of the elevator, then parang dito mangyari is i-subtract, no? Yung gravity and A. Okay? Gravity and A. So, that is equal to 1,150 times 9.81 minus the acceleration na nakuha kanina, 0.684. Okay? And this should be the answer. No? The tension. And dapat the same. Dapat the same yan sila. No? This book, by the way, uses gravitational acceleration na 9.8. One thing na i-take note ninyo, no? It uses G equal to 9.8. You see? 9.8 ito. 9.8 ito. Di ba? So, from now on, no? For physics problems na you somewhat see sa book na ito, try to use G equal to 9.8 instead of 9.81 meters per second squared. Okay? If you keep on studying this book, you would familiarize some of the problems, familiarize yung figures nila, no, in the book. Okay? And also, the author rounded up values dito. A is 0.68. Okay, good. Now, I want you to screenshot this and try to solve at home, no? Try to solve at home. Okay, I'm not gonna... parang ang solution nito, ng problem na ito is nasa libro, no? Nasa solutions manual. Look for it. Okay? Screenshot. So, both are walang hang, no? Na siya sa plane. Incline and this level plane. Now, how about this one? How about this? A small mass M hangs a thin string and can swing like a pendulum. You attach it above the window of your car, as shown in this figure. When the car is at rest, the string hangs vertically. Okay? What angle does the string make? What angle does the string make? When the car accelerates, meron palang additional. When the car accelerates at a constant acceleration 1.2 meters per second squared. Okay? So, paano yan? Paano to? Paano to? Parang na-mention to sa ni Sir Tariga sa discussion niya, no? If mag-accelerate to, okay? Of course, alam niyo na what would happen. So, mag-swing na siya, di ba? Pag-accelerate. So, if ipa-accelerate to natin to, no? Gagawin siya. If the car goes towards that direction. Tama? No? From like that, if walang acceleration or if constant yung velocity, no? Ganun lang. Pero if meron na acceleration, ganun, yan. Until merong angle, no? Merong angle na the string makes with the vertical. So, ano yan? Ito yung mga forces involved in this pendulum, no? Yung weight niya, that is, of course, going downward, at saka yung tension. Okay? Yung tension dyan sa string. And ito lang, di ba, yung involved forces. No? Ito lang yung involved forces. So, if, ano natin to, this is the weight, which is equal to mass times gravity. Ito naman yung tension. But there is no given mass. The mass is just variable m. Okay, variable m lang yung mass. Okay? Now, where to find this angle theta? No, and ano yung other force na involved? It doesn't seem right. No, walang other force na involved. Well, yung force na involved dyan is a reverse effective force caused by the acceleration. No? So, if, di ba, if mag-summation of forces tayo equal to mass times acceleration, not equal to 0, sorry about that, okay, equal to mass times acceleration, ganito. It's t sine theta. What is this t sine theta? That is the component along the vertical. Along the horizontal. Okay? I forgot to include that. I-draw ko na lang. I-draw ko na lang dito. Ito yung component na andyan, no? That is t sine theta, opposite yan of angle theta, equal dapat yan to mass times acceleration. Now, hindi natin include yung weight, di ba? We're supposed not to include the weight. No? But yun nga, ano yung mass? Well, saan natin makukuha yung ano? Yung T? Well, if mag-summation of forces tayo sa ano, sa vertical, okay, dapat summation of forces vertical is 0. Diba? Sa vertical. No? Okay, wait sa. Kita. So, sa vertical, dapat summation of forces is 0. So, wait. So, yung mangyari dyan, the tension cosine theta is equal to the weight, no, which is mass times gravity. Tama? Tama yun. And if we are to divide them, no, i-divide natin sila, no, the left side nito, t sine theta over t cosine theta is equal to mass gravity, mass acceleration. Okay? We could cancel the t. Diba? We could cancel the tension. No? So, it will become tangent of theta. Of course. Okay? Sine over cosine is tangent of theta. And equal lang yan to the gravity over the acceleration. Okay? Another way to solve that is dito, no? Para bang gawin nating reverse effective force yung mass times acceleration. Again, no? The reason why parang gumanon siya, no? Is because of the acceleration, no? Because of acceleration, merong reverse effective force. No? If isalin natin yan, no? Ito yung reverse effective force, MA. Andito, pwede na tayo mag-summation of forces equal to 0. Now, if we are to involve na the MA, no, in that system. Okay? So, parang naka-equilibrium na siya. Dynamic equilibrium. No? And that is ganito. Ma-solve natin by making this MA, ito MG, and ito theta. Now, force triangle. The tangent theta is MA over G or A over G. So, this the same, no? So, if the acceleration is 1.2 over 9.81, arc tangent niya is 6.97 degrees. Okay? So, yun yung angle of inclination niya. Now, if calculate yung tension, of course, ano lang, i-equate mo lang yung T cosine theta and the weight. No, if there is a given weight, no, pero yun nga, wala mang given mass, walang given mass. No, so this T would be in terms of mass. No? Yung second question ito from the book is ito, when the car moves at a constant velocity, v equal to 90 kilometers, what does the angle of the string make? Well, yung sagot niyan by is 0. Okay? If constant yung velocity, no? Kahit malakas yung takbo niyan, no? Imagine yourself, okay, always ko itong na-mention sa, sa class. If nasa bus ka or nasa jeep ka, bilis yung takbo, no? Ng jeep. Pero it's not accelerating. It's moving in a constant speed. It's not increasing, not decreasing. It has attained a velocity of 90 and it runs at a constant rate. Of course, parang walang movement, no? Meron lang magiging movement if there is a sudden change in velocity. No, either gaganon tayo or gaganon. Depende if mag-accelerate papunta doon, gaganon tayo because of the reverse effective force. No? Gaganon naman tayo if biglang mag-decelerate. Okay? Because of the deceleration. No, but if mabilis yung takbo, kahit sobrang bilis niyan pero hindi nag-accelerate, no? Walang movement. The same goes dito. It stays vertical, di ba? If it moves at a constant velocity. So, we can say theta is 0. No? Theta is 0. Yes ba? Now, later, mag-discuss pa tayo, no, ng mga other problems, work energy equation and impulse momentum taken from the book. No? Taken from the book. Okay, so let's have a break muna. Okay? Break muna tayo 30 minutes, then balik tayo. Additional problems from the book. No? Work energy and if kaya, mga linear momentum problems. Okay? Sige. Break. A rotational translation then as well, no? We are to discuss rotational translation also taken from the book. Right? Alright. Sige, break muna. Okay? Magpatuloy tayo. Merong 28 viewers, konti lang. Hi sir, ask ko lang po, ano pong reference niyo po sa probability? Yun po sanang kagaya ng binibigay niyo pong question sa exam, Bayes theorem. Pansin ko kasi hirap po ako doon. Sinek ko po kasi yung Litons and 50 challenging problem. Muntik na po akong mabaliw. Alam. Ikon din po sana. Alin po? Yung concept-based po sana, sir. Salamat po. Okay, medyo marami, no? Yung reference ng examiner sa probability, yung isa is physics, sorry. Let me look for it. Wait muna. Saan ba yung book? Ito. Statistics for engineers, no? Marami na siyang kinuha from this book. If someone could find a copy of this online, no, the better. Hindi pa ako nakapaghanap ng kopya nito online. No, I bought this for 1,000 plus, no? Matagal na, 2016, naan. Yan yung mga binibigay ko sa mga discussion, no? Discussion natin sa probability and also mga exam. I took them sa book. Meron ding statistics for statistics in a world of application by Kizansky, no? In a world of application. If you could find a copy of this book, PDF copy, the better. Okay, let me show this sa inyo, ha. I-paste ko sa wait muna. Ito na book. Yun na siya, no? By Ramakant Kazani, no? Marami din siyang kinuha from that book. However, hindi ko mahanap yung nito, yung PDF file nito, no? Okay, if someone could look for it, the better. Pwede kang makabaro nito sa archive.org. Yan yung ginagawa ko. I could borrow it every hour, you know, like good for 1 hour yung pagbaro, no? Like paunahan siya. So nagkukuha ako ng problems from that book kasi yung examiner nagkukuha din, no? So pwede niyong i-search yan, archive.org. And also AP Calculus, Barron's AP Statistics. Barron's AP Statistics. Yan yung mga tatlong libro, no, na reference ng examiner. AP Statistics. Let me try if I could upload it. Wala akong niyan. PDF dyan, only an EPUB. No? Pwede nyo siyang ma-search. Barron's AP Statistics. I-try ko ha if makapag-upload ba ako. Uploading it right now. This is not a PDF but an EPUB. Ina-upload ko ngayon sa Padlet. Okay, loading man. Anyway, magpatuloy muna tayo. Magpadayon muna. Let's discuss the next chapter in this book by Giancoli. Kanina we focused on the chapter on Newton's laws of motion, dynamics, Newton's laws of motion. Ngayon naman, chapter 5 in that book is circular motion, gravitation, no? Nasa gravitation ito na part. And this is parang first few problems, no? First problem or example problem in that book. Okay? So the question is, a 150-gram ball at the end of a string is revolving uniformly in a horizontal circle of radius 0.6. As in this figure, the ball makes 2 revolutions in a second. What is its centripetal acceleration? Okay, what is its centripetal acceleration? Paano ito masolve? Ano yung centripetal acceleration? So if this is the ball at the end of this string, no? Ikot-ikot yan, ikot-ikot lang, ikot-ikot. How to find the centripetal acceleration yan? Okay? Centripetal acceleration. Ang formula ng centripetal acceleration, why it's not moving? The formula of centripetal acceleration is this. Now, the acceleration, okay, centripetal, A sub C yung i-denote natin yan, is equal to V squared over R. Now, yan yung formula. Okay, V squared over R. Okay, that acceleration is towards the center of curvature yan, no? Every time an object moves in a circular manner, there is a acceleration, no? An acceleration towards the center. We call it the centripetal acceleration. Kahit na this object is moving at a constant rate, kahit yung velocity niya is constant, hindi nag-a-accelerate, there is always a centripetal acceleration. No? And to find that, we simply have to use the formula V squared over R. V is the tangential speed or velocity, no? And yung R naman is the radius, of course, radius of curvature, no? Ganun. So, in this problem, hindi given yung speed, hindi rin given yung merong radius is 0.6. Hindi given yung speed. But the given is this, the ball makes 2 revolutions in a second. 2 revolutions in a second. We call that the frequency. No? Frequency na siya. Okay? The number of revolutions it makes per second. Okay? The number of revolutions per second. Okay? Ganun. So, pwede natin kunin yung period nito, yung period of a circular motion is equal yan to the reciprocal of the frequency. No? The period is how fast it rotates. No? How fast it revolves. No? 360 degrees. Ilan yung 1 revolution? No? I mean, yung time ba? No? Yung time in revolving 360 degrees, 1 circumference of a circle. No? So this is equal to 1 over the frequency. Now, the frequency, again, ito, now is that given 2 revolutions per second, no? So 1 over 2 is the period. Okay? The period is sorry about that. 0.5 second per revolution, no? need natin to get the angular speed. Now, the angular speed, this is denoted as angular speed. Denoted as omega, okay? That is equal to the circumference, which is 2 pi r over the period. Okay? 2 pi r over the period. And that is equal to 2 pi, 2 times pi, times the radius, which is 0.600 meter over 0.5 second per revolution. Okay? Evaluating that would give us an answer in revolution per second, no? Sorry, in meter per second. That is, wait, parang nalito ako. .54 na 7.54. Ayan dapat. Okay? Ayan dapat. Okay, 7.54 meters per second. That's how fast it rotates, no? Wait, sorry. This is not omega. This is the tangential speed. Naunsa man ni? Tangential speed. Okay, V. The omega is ano yan? 2 pi over the period, no? Like yung angle over the period, no? Yan yung omega, but the tangential speed, okay, is the is 2 pi r over time. Okay? 2 pi r over time. Circumference, na ilan yung ma-rotate at distance ma-travel in a circular manner over the period. Okay? So we can now calculate the centripetal acceleration, no? Centripetal acceleration denoted as A sub C. In the book, it's denoted as A sub R. Na ako, I used to denote it A sub C. No? Mas okay siya, di ba? If centripetal A sub C. So, this is 7.54 squared over the radius. The radius is 0.6. Okay? And that is 94.753. Okay, 94.753. So this is, of course, in meters per second squared. Okay? That's how fast it goes, no? Into the center, no? Centripetal acceleration. Okay, madali lang, di ba? Madali lang. Now, i-interconnect natin to, no? Yung next problem nito, ito yung solution from the book, by the way, no? Kana siya. Alay ko kasi na-deny na ano tawag nito? Decide na magkuha na lang talaga ako ng problems from this book. No? Now, another problem that may come out sa board exam or maybe had come out already, nakalimutan ko na, no? So sobrang raming problems na lumabas na sa board. Seems like lumabas na ito, no? I'm gonna look for it again. Parang meron na nga, parang may lumabas na nga na ganito, no? Estimate the force a person must exert on a string attached to a 0.15 kilogram ball to make the ball revolve in a horizontal circle of radius 0.6 meter. The ball makes 2 revolutions per second. Ignore the string's mass. Okay? Ignore the string's mass. Bali, ilan daw yung force na exert ng person, no? If paikutin niyo yan in a horizontal circle like that, no? Not vertical, but just horizontal. Okay, just horizontal. No, parang, yan yung figure. Okay? So, paano? Well, dapat yung force na exert ng person, no, like as he pulls that string, no, back and forth, okay, to make it rotate, di ba? Mag-rotate yan if you would pull it back and forth. Ganun, no? Uh, if may string ako dito, let me check. Ito, let's say ito. No, if I'm gonna, yan, if I'm gonna pull it back and forth, mag-rotate, di ba? So, ilan yung i-pull niya? Na so that yung radius is 0.6, the same kanina, and also makes 2 revolutions per second. So, the same ito, no? The t is equal to 2.00. Yan yung, no. F pala yan. F is 2. Yung t is 1 over 2. That's 0.5 second. Okay? And the r is equal to 0.6. So, if we're to calculate the centripetal acceleration, unahin natin yung v. And again, v is equal to 2 pi r over t. And we have solved this already kanina, no? 2 pi times the radius 0.6, okay, over t, which is 0.5. Yan, 7.54 meters per second. And meron tayong nakuhang centripetal acceleration. And again, the centripetal acceleration is equal to v squared, 7.54 squared over r, 0.6. V squared over r. So, 94.754 meters per second. Now, i-relate natin to kanina. Di ba? Kanina, if merong acceleration, if ma-accelerate to the right, yung isang object, or let's say yung truck, there will be a reverse effective force. No? So, same goes dito. There is a centripetal acceleration, an acceleration towards the center. So, if there is, then there will be a reverse effective force with a magnitude equal to mass times acceleration. And that reverse effective force is what we call the centrifugal force. Diba? We call it the centrifugal force. No? Denoted as CF. The centrifugal force is equal to the mass of the object and the centripetal acceleration. So if we are to include now the velocity, so it's v squared over r, mv squared over r, or wv squared over gr. That is the centrifugal force, and this should also be the tension that the person must exert, no? The tension to exert so that it will rotate this speed, okay? That is equal to the mass, which is 0.15 kilogram, okay? Then times the centripetal acceleration, yung nakuha na diretso, 94.754 meters per second squared. Okay? If evaluate natin yan, the result must be in Newton. No? So that is 14.213 Newton. No? That's how the author of the book solved. That is same. But he rounded that off to 14 newtons. The author of the book rounded that off to 14 newtons. Okay, simple na siya, di ba? Simple lang, no? Please understand that. Okay? Merong centrifugal force. So that should also be the tension that the object, that the person must exert. No? Na merong problem na I think binigay ko sa module 5. Let me check now if naibigay ko ba talaga to. Yung chord na problem. Wala. Hindi ko pala naibigay, no? Ito, I'm not gonna I'm just, take a screenshot lang, no? From the book. Yan. Uy, di man maklaro, sir. Ito. Medyo basic lang to, no? Yan. Ay, wala pa di. Ito. So, kanina, na rotate in a horizontal circle yung object. Ngayon, vertical. Okay? Rotate vertical. A 0.15 kilogram ball on the end of a 1.1 meter long cord with negligible mass is swung in a vertical circle. So, vertical circle na. Bali, ito na yung figure. Parang the same kanina, no? The same kanina, but kanina it was horizontal. At ngayon, pag ganito na siya. The question, determine the minimum speed the ball must have at the top of its arc. Now, ilan daw yung speed dito? Dito, no? At the top of its arc. So that the ball continues moving in a circle. No? Dapat mabilis yung pag-ikot-ikot niyan. Okay? O baka ibigay ko ito sa final pre-board ha. No? I used to give this sa mga pre-board. Kining a problem. No? I thought I was able to give this sa module 5. Wala di ay? Okay, wala nga, no? Hindi ko nga naibigay. Okay. So, in order for the in order for the ball to continue moving in a circle, dapat yung speed is sufficient so that malaki yung centrifugal force niya upward than its weight, no? So, bali dito, yung gawin lang natin is make the centrifugal force greater than the weight, no? Centrifugal force greater than the weight or greater than or equal to. Kasi if the centrifugal force is less than the weight, na hindi yan mag-circle, no? Yung pag-rotate niya, di ba? Kasi mas mabigat siya compared to the force that goes up, no? So, dapat yan yung gawin. Centrifugal force must be greater than the weight. And the centrifugal force, as we have just discussed, is equal to the mass times the centripetal acceleration. So, this must be greater than mass times gravity. No? So, pwede nating makancel yung mass. So, dapat the centripetal acceleration must be greater than the gravitational acceleration so that it continues to move in a circular motion or pwede or equal to, no, greater than or equal to, instead of just or equal to, greater than or equal to, no? Siya. And we know, di ba, that the centripetal acceleration formula is v squared over r. No, so dapat v squared over r must be greater than or equal to g. No? So if we're to solve for g, for the velocity, it must be greater than or equal to square root of g times r. Square root of g times r. If evaluate natin yan, na square root of 9.8, let's use 9.8 kasi yan yung ginagamit ng author, 9.8 meters per second squared, multiply it by 1.10, okay, we would get 3.28 meters per second. No? So, yan dapat yung speed, minimum speed ng ball at the top so that its arc, so that the ball continues moving in a circle. Kana siya. No? If, let's say, 3 lang yung velocity niya kasi mahina yung pag ano mo, hindi yan mag-perfect circle. If greater than 3.28, then perfect circle pa rin. Diba? Now, question, calculate the tension in the cord at the bottom of the arc assuming the ball is moving at twice the speed. So, in this problem, yung gawin lang natin is multiply this by 2 kasi yan yung magiging speed. Now, when it's at the bottom, that is twice of 3.283 meters per second. So, that is 6.566 meters per second. Now, and if we are to calculate the centrifugal force when it's at the bottom, the centrifugal force is equal to mv squared, which is, again, the mass, 0.15 kilogram, then times the centripetal acceleration. Dito ko na lang ilagay, the centripetal acceleration na when it's at the bottom is equal to 6.566 squared over r. The r is equal to 1.10 meters. No? And that is 39.193 meters per second squared. So, multiply yan ito. Okay? Mass times acceleration in meters per second squared. This is the centrifugal force. The centrifugal force is 5.879 Newton. Now, the weight is equal yan to mass times gravity. Now, so 0.15 times 9.8. Now, let's just use 9.8. That is 1.47. Okay, so the tension, it must be equal to the sum, no? Yung tension ng cord must be equal to the sum of the centrifugal force that goes away from the center and the weight. Diba? I-add natin sila. Okay, so that is equal to 5.879 plus 1.47. That is 7.34 or 359 Newton, no? Sa book, the same, no? The same din yung result. Okay, yung part A, let me show you the part A. Ako, nag-guide lang ako sa inyo, no? I want you to start solving this book from now on. Okay? Please, no? Simulan nyo na. I wasn't able to, provide this sa inyo right away, no? Hindi kasi ako yung nag-dynamic sa inyo. Si Sir Taris. No? Pero, yung principle, grabe, ang ganda. Yung mga na-discuss na examples ni Sir Tariga, sobrang ganda nun, no? I hope marami kayong natutunan, no? So, yung sagot for the second part is 7.35. I-add natin yung centrifugal force and the wait, that's equivalent to the tension. Okay. Now, siguro you would encounter this problem this principle no, sa board exam. Yung Newton's law of universal gravitation. So, please familiarize this. Okay? Familiarize ninyo. Every particle in the universe attracts every other particle with a force that is proportional to the product of their masses, and inversely proportional to the square of the distance between them. This force acts along the line joining the particle. So let's say there's a particle in a universe, then say another particle or another planet. They have masses M1 and M2, no? So there is a force of attraction. Now the force of attraction or gravitational force is equal to this G times M1 times M2 over R squared. Okay? Where G is what we call the gravitational constant, no? And andyan yan sa sa Canon calculator. Okay? Also sa Casio. Andyan din yan. Okay? G is 6.67 times 10 raised to negative 11. No? The gravitational constant. Let's have an example. Okay, baka lalabas to, no, sa board exam. Simple lang ito, madali lang ito, no? Ang sa inyo lang, i-familiarize nyo lang yung problem, no? Yun yung importante ngayon. Ito, can you attract another person gravitationally? Can you attract another person gravitationally? A 50 kilogram person and a 70 kilogram person are sitting on a bench close to each other. Estimate the magnitude of the gravitational force each exerts on the other. So how to solve that? Okay, so again, we're gonna use the formula. Now, and the formula is as simple as this. Now, the gravitational force is equal to G times the product M1 times M2, no, over R squared. R is the distance between the two, no, between the two objects. Okay, so if we're to solve this, the G again is 6.67, okay, times 10 raised to the power of negative 11. Okay, mana siya, times 10 raised to negative 11. That is in Newton meter squared kilogram per kilogram squared. Now the masses are 50 kilograms and 70 kilograms. Okay, then over the square of the radius. No, I mean the distance between these two persons. Okay, I'm just gonna make this times 10. Yan. Para consistent ako with my unit here in MathCAD, Newton meter squared over kilogram squared. Now, evaluating that gives me, scientific ba? Okay. Ito yung na-calculate na sagot. Okay. The FG in Newton is 9.338 times 10 raised to negative 7. Now, and yung sagot ito is, ang unit ito is in newtons. No? Sa book, sa reference book, baka kopyahin lang to ng examiner. No? Malaking chance, in almost every exam, kumukuha siya ng problem from this book. Trust me lang, no? Yes, kumukuha siya. So, yung sagot niya dyan is 10 raised to negative 6. Now, he rounded that off to 10. Instead of 9, he made a 10 raised to negative 6 Newton. Okay? So, muna siya ba Muna. No? Another problem. Ito baka lalabas din sa board exam. Okay? Para masanayan natin to. And let's use the calculator, no? Let me open muna my calculator. And hanapin natin yung G sa calculator, no? Parang constant 35 yan, no? Constant 35 man siguro yan. Ito yung next problem. What is the force of gravity acting on a 2,000 kilogram spacecraft when it orbits two Earth radii from the Earth's center, that is a distance RE 6380 kilometers above the Earth's surface? Ano daw? Yung distance niya daw from the Earth's surface is 2 Earth's radii, no? Ibig sabihin yan, if i-draw natin siya, ito yung figure, no? Ito yung spacecraft. Okay, its distance, no, from the surface is 2 radii. So total distance nila from their centers is 3 times the radius of the Earth. Okay ba? 3 times the radius of the Earth. So we are to find the force of gravity acting on these two. Force of gravity. Okay? So the force of gravity can be solved using, again, G times M1 times M2, no? Over R squared. Magagamit ba natin yan? No? Pero dito, yung mass ng Earth is given, but the mass of the object is relatively too small, no? It's too small. Parang merong another formula na gagamitin natin dito. Let me look for it, ha. Yung formula na gagamitin is ano? At the surface of the Earth, ito, no? At the surface of the Earth, Fg, force of gravity is equal to mass of the object times gravity. Mass of the object times gravity, no? So, yan yung gagamitin natin. So, at a distance twice of RE, let me show you na lang the solution ng author, no? In a way, if ibibigay ito ng examiner, I'm sure na kokopyahin niya lang. Ganun talaga. Okay, ito yung solution sa book. Okay, we could plug all the numbers, but there's simply your approach. The spacecraft is twice as far from the Earth's center as when it is at the surface of the Earth. Now, therefore, since the force of gravity, Fg, decreases as the square of the distance, the force of gravity on the satellite will only be 1/4 its weight at the Earth's surface. So, parang ganito, no? Force of gravity is mass times gravity at the distance of the Earth. So, the Fg is 1/4 as great, 1/4 of mass times gravity. So, 1/4 of 2,000 kilogram times 9.81. No? Ganun lang pala. So, that is 4,900. Okay? $4,900. Yung next example problem from the book is actually naibigay ko na sa sa module natin, parang last module. Ganun siya. Okay. Yung gravity on Everest, no? So 9.77, naalala niyo pa ba 'yan? No? Again, this G ba? This G, andito yan. Let me turn on my Canon calculator. Constant C value, shift, convert, parang 35 man siguro yan. Ano, gravity pala ito. Wait sa shift, sorry about that. Hanapin natin. This capital G, no? Pwede nyo lang mahanap. And tingnan niyo sa ano, sa, ito. 39 pala. Constant 39. Tingnan niyo sa Casio, to those that are using Casio, no? Hanapin niyo yan. So that if makalimutan nyo, you could use yung stored value dyan sa calculator. Walang katanungan. Saan galing yung 0.5, sir? What 0.5? Siguro ito, 0.5. There is the, ano, the period. 1 over the frequency. Uy, another book pala na ginagamit din ng examiner, no, is the another probability book ba is the 50 challenging problems in probability with solution. I uploaded that also sa website. No, I mean sa reference, no, Padlet reference. Okay? Now guys, please do not limit yourself sa mga example problems. No? Again, nagbibigay din ng mga problems yung examiner taken from the supplementary problems, no? Additional problems na walang solution, no? Yung solution nasa solution manual, no? Though yung author na solution manual is not anymore si John Coley, but si Bob Davis, no? But his solution is good, no? Pwede niyo lang gamit. I bet the examiner is using this solution manual. No? Lahat problems merong sagot dito sa solution manual. No, so sagutin niyo yung mga problems from this book. Okay? Na baka in our next miscellaneous class magpatuloy tayo. No, patuloy tayo sa ano natin. Dynamics natin, no? So far nasa chapter 5 pa kasi, no? Hanggang ano pa ito? Hanggang what chapter? Hanggang medyo marami. 33 chapters, no? Kasi marami ding binigay yung examiner, no? Na nasa mga electromagnetic na problems, magnetism, no? Vibration, sound, oscillation and waves na book ay na chapter in that book. So please, unahin nyo yung mga example, no, from chapter 1 to chapter 33, and then intindihin nyo yung mga principle, then try kayo solve sa mga example problems. Okay? So at least yung ano ninyo ngayon is yung guidance namin, guidance ko, no? Study this book. Ha? Study this book. Okay, pwede tayo mag-end early ngayon so that you could have time to study pa, no? To study this book. Pagtulong-tulungan kayo with your classmates, okay? No? Baka next week, ano naman tayo? Discuss tayo ng impulse momentum, no? Meron pang schedule next week, di ba? Na miscellaneous, no? Impulse momentum at saka meron pala ako ipakita sa inyo, no? I forgot to I almost forgot. Ito ay. Oops. Wait ha. A problem that came out noong 2017 na kini siya nga problem. Ito. Yan na problem. Oops. Ito na problem, no? Geosynchronous satellite problem. Okay? Lumabas yan. May 2017 board exam. May 2017. And yun nga, no, from 2015, from the time we started, up to last board exam, it's been taken problems from the book. So, parang suki niya, no, yung mga problem, yung mga problems na binibigay, example problems. Okay? At saka, yung extra problems, no? But unahin mo yung mga example problems. No, this is somewhat, nakakalito, no? Kasi, the question is, determine the height above the Earth's surface such a satellite must orbit. No, pero yung choices niya, naka-cubic meter. Naka-cubic meter. Why is that? Kasi, from the book, no, yung solution is eto, no? And eto lang yung binigay ng examiner, no? 7.54. This is an actual copy ng board exam, no? From the actual copy of May 2017 board exam. No, na-leak. Na-leak. Ewan ko sino yung nag-leak niyan. Okay? So, imagine, no? R sana yung pinapahanap, pero yung R cube yung andun. Mabuti, no? Naka-M cube ito, no? Even though it asks for the height. No, doesn't make sense na M cube. Okay? So, dapat naka-meter lang. So, that is the cube root of that sana. No, yung exact answer is 4.22 times 10 raised to 7. Okay? Pero the examiner made that as the answer. No? So, he used, again, kana siya nga formula. Okay? So, baka sa board exam ninyo, ito naman yung ibibigay na examiner or ito, no? Determine the height, determine the satellite speed and compare to the speed of the satellite orbiting 2,200 kilometers. So, this would be the answer. If yun yung ipapahanap, okay, part B and C, no, 3,070, no, and 7,770 meters per second. So, pwede maluksong. So, problems from this book, okay? Nagkakaintindihan ba? Andyan pa ba kayo, guys? Huy! Are you still with me? 39 viewers. Medyo maraming problem, no? At konti na lang, 20 days na lang. Kaya pa ba? Less than 20 days. Kaya nyo pa ba, guys? Less than within 3 weeks? Kaya pa, no? Wag lang magsayang ng oras. No? Advice ko sa inyo, focus. Dapat yung lakad lang if you are an online student. Yung lakad lang, magsimba, ano? Balik sa bahay, aral. Sa mga nag-face to face, puntang jersey lang, balik sa bahay, or magsimba. No? Pwede, lesson na yung time, no? Sacrifice ka talaga, no? Kailangan na hindi na manglaba, magpalabada na lang. Yeah. To save time. Okay? Kasi if ikaw pa yung maglalaba, ikaw pa, mapapagod ka pa, ipagod na, ayaw na mag-aral. Advice ko yan, ha? Advice ko yan. No? Or ask your parents, no? Magpatulong ka sa kanila, no? Na sila na lang maglaba. Okay. Napakarami pang gusto kong mai-discuss. But sobrang rami. Sobrang rami ng topic, no? So do your part. No, please do your part. Okay? Again, we could not discuss them all to you, but we have a solutions manual. No, so mag-attempt ka mag-solve. After you have solved the problem, look at the solutions manual if tama ba yung solution mo. That's the effective way now to understand a topic. Mag-attempt ka talaga by your own. Know the principle, attempt, look at the solution, tingnan nyo kung tama ba kayo or kung may mali, saan kayo nagkamali. Take note of that, then apply that again to the other problem. Ganun. No, di ba? Effective yung learning ninyo. I know kasi means sa inyo, no? Many sa inyo mag-open notes ba? Solve problem, mag-follow sa solution. That is not effective. That is not effective, no? Know the principle in that problem. Pwede. In that problem, find, if you don't know the formula, search mo lang muna or know the principle. Then attempt using those formula or principle, attempt solving it. Then later, look at the solution manual, no? And i-compare mo, if tama, good. If may mali, take note kung saan ka nagkakamali, no? Yan yung effective na pag-aaral. Okay ba? Okay ba, guys? 37 viewers. Hey, okay ba kayo dyan? Ako pagod na, no? Meron pa sanang additional problems. Next time na lang ito, no? Next time na lang yung iba. Ha? Hanggang dito lang muna tayo ngayon, no? Rest muna tayo for a while, then please explore this book. No? Explore this book. Okay? So that's it. Goodbye everyone. And God bless sa inyong lahat, no? God bless you guys. Bye!